Okay, thanks a lot, Fernando. Yeah, welcome from my side as well to this first Motors Academy webinar. Well, let me start with a short personal story. 2 years ago, I went on holidays to southern Italy with some friends, and we wanted to travel eco-friendly, so we drove instead of flying. And we used the navigation system to save some time and fuel. Well, in fact, we used 3 different navigation systems. I have one built in my car. It's a Japanese car. My friend has one built in his German car. And then there's, of course, Google Maps on my wife's phone. So very soon we found out that all 3 navigation systems give us a completely different route to follow. They were not consistent, and we didn't know which one to trust. So we got frustrated. And this frustration reminded me of the same kind of frustration that we observed during a workshop back in 2018 organized by the European Copper Institute, and that lied at the basis of the project ID for this streamSAVE project. So let me explain. We are talking about Energy Efficiency Directive, and I guess you're all familiar with it. If you're not, I would welcome you to register for the Energy Efficiency Academy, which is another academy run by the Leonardo Energy platform, and which will dive into the Energy Efficiency Recast Directive implementation phase. Every month we will have a webinar there, and it's a collaboration with the Odyssey Muur project. I can share the link later on. Okay, but back to Energy Efficiency Directive. Within that directive, you have this famous Article 7. Now it's called Article 8 since the recast. But it's a very known article in terms of achievement of energy savings in the European Union. So we're talking about energy efficiency obligation schemes and alternative measures installed by the member states. But what we observed after a few studies years ago at ECI is that those catalogs of implemented energy saving measures at EU member states, they were lacking in some more advanced technical saving actions, even saving actions that they were known for high saving potentials that they could bring to the member states. So a few examples of such measures is that electrification of road transport, rollout of residential heat pumps, heat recovery in industry, building automation, and of course, accelerated replacement of electric motors, the one that Zhao will feature. So we were curious, how come that some energy saving measures with high potential were underrepresented in the member states' programs? And during a workshop in 2018, we gathered input from member states, and the main reason for them not to implement those savings was, in fact, the lack of straightforward calculation methodologies, or at least some indicative values or parameters. So in other words, tools to calculate the deemed savings, because those savings are crucial for reporting to the European Commission and make sure that the measures contribute towards meeting the targets outlined in the directive. And okay, there the idea of a new project arose with the goal to address this gap, and a project that really created a framework with easy and reliable methods, and that values for concrete energy saving actions in various sectors. So in other words, a project that should try to streamline those different kind of navigation systems in the cars of many member states. So there's where streamSAVE was born, and as Fernando already said, streamSAVE has come to an end since August. It started back in the COVID days in September 2020. We gathered 12 partners from 10 different countries, covering a wide variety of experiences and backgrounds. The coordinator was Nele Renders from the VITO, the Flemish Research Institution, and the European Copper Institute, the organization that I work for, and also the Institute of Systems and Robotics of University of Coimbra, where Zhao works for. They were both part of the consortium. And the other consortium partners are listed on the screen. I will not name them all, but you can see them. So what was the aim of the streamSAVE project? Capacity building. Capacity building mainly through knowledge exchange, to dialogues, and to one-on-one support to the member states. So developing streamlined calculation methodologies to estimate bottom-up energy savings, and that way also to answer the need for comparable progress reporting to the Commission. And of course, also while acknowledging the diversity of the member states' reality, which is also a challenge when talking energy saving calculations. With the main goal, of course, or the result to achieve additional energy savings by 2030. And of course, we were anticipating there to the increased energy saving target that was already then be expected from the Commission's raised ambition under the European Green Deal, of course, and the EED recast that was. Here you see the 10 saving actions that were covered by streamSAVE project. Again, I'm not going to read them, but maybe more talk about how did we select it, some criteria. First of all, they needed to be actions that were underrepresented in the catalogs of implemented savings measures. They had to be had to have high potential on energy savings documented in literature. And they should be considered as a priority by national public authorities. And how did we discover that? Well, we conducted 2 surveys among national authorities in the course of the. And for today's session, of course, this 1 out of 10 saving measures, replacement of old electric motors, was of course, but Chow will jump into that later. Very briefly, how did we realize the objectives with streamSAVE? Again, as I already told, 3 pillars. 1, knowledge facility, basically gathering all the knowledge we had within the consortium, but also outside the consortium by engaging stakeholders, bringing the knowledge together, and based on that, build and develop methodologies and indicative values for each of the 10 saving measures. Next pillar is the peer-to-peer dialogues to share experiences with the sectors, with the member states, basically to validate the methodologies that we developed. This was organized by small dialogue groups per action. And then one-to-one technical support by consortium experts to address more specific needs from individual member states from the consortium. And all this was facilitated by an online platform, the streamSAVE platform. Platform, by the way, where you can still find all the methodologies developed. You have the link there on the screen, and I will share this in the chat later on. I'm honestly not sure how long this link will be active. It was today, but as Fernando already mentioned, streamSAVE has finished, so I'm not quite sure on how long we will keep this link active. So if you want to dive into the details of the methodologies, please do so. We can say that streamSAVE was quite effective and quite successful because we improved policies in 13 countries, meaning the 10 countries that were involved in the project, and also 3 replication countries, countries that associated during the project. I'm not going to read out all the results and all the policies that we could impact here. In the final report of the streamSAVE project, it mentions 30 energy efficiency policies that will probably be affected by streamSAVE calculation. You find the list in the report there. And again, here I put the link on the screen with the QR code where you can immediately download this final report of streamSAVE with all the outcomes earned. So that's it for streamSAVE. And as already said, this project was in the past, but even after the project ended, it is very relevant. And maybe I should say that now, when member states are really in the midst of implementing the Energy Efficiency Directive recasts and translating them into national legislation, those calculation methodologies are extremely relevant now and are timely. So as you all know, Energy Efficiency Directive was revised. The new one came into effect on the 10th of October this year. And it erases the headline targets on the EU level, making it binding also for EU countries to collectively ensure this additional 11.7% reduction in energy consumption. But for today, maybe even more important is that this revised directive also more than doubles the annual energy saving obligation. So this famous Article 7, but now Article 8, by the year 2028, which is kind of like tomorrow. So this Article 8 still is one of the key policy instruments of the directive to meet the headline targets, and also for individual member states to drive energy savings in end-use sectors, all the end-use sectors, in fact, like buildings, industry, and transport. So this is where our topic of today comes into picture, because accelerated motor replacement, one of the 10 that we studied with streamSAVE, in fact, is one of those promising and underrepresented energy saving measures. And it is eligible under this Article 8. If you dive into Annex V of the directive, which I wouldn't suggest because the main idea is on your screen now, but there you can read that member states can claim the full credit for policies that accelerate the uptake of more efficient products. Two requirements there, kind of logic. First of all, member states should prove additionality, meaning that they should prove that the savings are achieved by the measure and wouldn't have occurred without the measure. And another requirement is that the member states can prove that the uptake takes place before the expiry of the average expected lifetime, or before it would usually be replaced. And of course, when reading those requirements, then you can sense a bit of a potential for frustration, like we all experience when using our navigation system and not being very certain which way to follow, because how are member states going to streamline the way they calculate average expected lifetimes, for instance? And how are we going to report on the additionality towards eco-design directive? So streamSAVE methodology will, of course, be of support and will make it easier for member states to integrate these actions into policy measures, but probably there will be needed more. And that's also a thing that we try to cover with this new project that Fernando already mentioned, the EU More project. And João will also mention that in his presentation. But now, why motor replacement is relevant and how can streamSAVE support member states in adopting this measure? I now invite João to the scene and hand over the mic to him. He will now elaborate on that one. So João, please.
Thank you, Didier. Hello, everyone. Thank you for attending this webinar. I will be, as Didier said, talking about the anticipated motor replacement. I will begin by trying to explain why is this initiatives of replacing motors before the end of life is relevant, and then I will go through the methodology that we developed on the during the streamSAVE project on the calculation of energy savings from replacing motors. Next slide, please. So why is anticipated motor replacement a good opportunity for energy savings? Well, the motors represent a large share of the electricity consumption worldwide. So in industry, it is estimated that motors represent around 70% of the electricity consumption. And there's also, of course, motors in buildings, in, for instance, HVAC systems and lifts, etc. And here in buildings, it is usually estimated that motors represent around 40% of the electricity use, which is also important. And therefore here, because their energy consumption is so large, even a very small increase in energy consumption represents a very large absolute saving. So next slide, please. So in Europe, because this the importance of electric motors and their savings was recognized at a few years ago, and so after included in the Eco Design Directive, there were introduced the minimum energy performance standards for motors already in 2011. So motors had to be at least IE2 efficiency levels. And then these requirements have been growing in stringencies. So now all motors must be at least IE3, and motors between 75 and 200 kilowatts must meet IE4 efficiency level. So this is the first time that IE4 requirements have been introduced in the world. So, but these requirements may not be enough if we want to reap the benefits of these savings fast. And next slide. And so why? Because so the motors age have generally been considered to be of around 12 years for motors between 1 and 7.5 kilowatts, or 0.75 and 7.5 kilowatts, and then 15 years for slightly larger motors, and for big motors 20 years and above. But what the evidence has shown is that maybe this is not true. So motors may last in service for much longer. So this is the result of a study carried out by the Swiss Energy Agency. They assessed 4,000 motors, a little bit more, and one of the things they looked at was the motor age, and you can see here that the motors, motors were much older than it would be expected. So 56% of motors were older than expected. And in the USA, which is the next slide, they carried out also an assessment it was published in 2021. And they also found that the majority of motors were at a very large, big lifetime. So also over at least 10 years. So, and you can see here that a large portion is UTC. This is unable to collect. And what this means is that either the nameplate was not readable, or that the person responsible for the motors in the plant was not aware of when the motor had been installed, so very old motors. And so you can see here that the large majority of motors are over 10 years old, or you can even look at that at 20. So it's over 50% of motors are older than that, which is a problem, because it means that the motors that are installed today, working today, are still inefficient, very inefficient, below I2 level. So if you can show the next slide, please. We have made an estimation of how many motors would be below this. What was the efficiency of the motors, of the installed base of motors in the EU 27? And we can see that in 2021, at least 70% of the motors were still below IE2, and 30% were even worse, so IE2 and below. So what this means is that by replacing these motors, we could achieve very large efficiency gains, and of course, a very large also savings in the electricity consumption and the corresponding emissions. So if we replace these motors that are IE2 class or below with IE3, at least IE3 motors, of course, it would be better if we replace them with even higher efficiency levels. The saving triggers would equal around 25 terawatt hours per year, which is a lot in Europe alone. And then if we replace them with even larger, with better efficiency motors, so IE4 or IE5 motors, and then we, at the time of the replacement, we do an engineering analysis, and we also carry out a number of correcting measures. So, for example, correct the motor size, which motors tend to be oversized, and or equipping the motors with variable speed drive when they are used in applications where variable speed is needed. If at the same time we also equip these motors with digital technologies and sensors that allow us to better control the processes, improve maintenance, etc. So if we use a variable speed drive, sometimes we may remove the transmission. There's also an efficiency gain there, and etc. So if we do all this, then the total savings will be larger than 100 terawatt hour per year, which is, of course, a large saving. So just for reference, it would be the equivalent to 30% of the natural gas import from Russia in 2022. So it is a very large saving. So because we recognize that this saving existed and it was additional to these are additional savings to the existing regulations. So we developed a methodology to help implementing agencies to estimate how much savings they would achieve by implementing programs to accelerate this replacement of existing motors. And the methodology was directed at 3-phase motors in the scope of the Eco Design Regulation, so between 0.75 kilowatts and 1,000 kilowatts. So we excluded the small motors. And these are 2 to 8 poles in both sectors, industry and the tertiary sector. So the methodology is very simple. So to find the energy savings, we just multiply the number of motors impact with their power, annual operating hours, then the difference in the efficiency between the installed motor and the new motor, and also the load factor. And for motors that are equipped with a VSD, of course, there will be additional savings, and so we multiply by a factor that accounts for these additional savings. Next slide, please. So this can be done on an online platform. this online platform is available also for the other priority actions, but here you just choose. We have provided some indicative values for the variables that you have to introduce in the formula that we showed in the previous slide. So, for instance, you select motors in this power range 75 to 375. In industry, working 2 shifts, 5 days a week, including variable speed drive or not. The end use also is important because of the for the calculation of the savings, because it varies with the end use, and then the efficiency of the new motor. If you want, you can introduce, if you have better values, so values collected in the field, for instance, or values that are more adequate to your own countries, you can introduce them yourself. But here, but if you don't have these values, we provide these indicative values that are some kind of average that will provide you with an estimate of the savings. So, and here you can see that which are these indicative values. So we provide values for the efficiency within these power ranges, and also for the number of operating hours and also these values for the VSD additional savings depending on the end use application. So we consider that the load factor is 0.6 in all applications. So the next step in the would be to choose the share of energy carriers. For the motors, it's only electricity, so you wouldn't have to change anything. But for others, you can choose the percentage of that is used by this energy carrier, and you can choose multiple energy carriers if that's the case. But in the case of motors, it's just electricity, so we just put here 100% for electricity. And then the next step would be it would show a page with all the values that you have inserted. So this next slide, please. Here, and then you just press calculate, and then it does the calculations by itself. So as I said earlier, you can input your own values if you have better values than the indicative values that are provided. If you have more accurate values, then you can insert them. But then you just press calculate, and it will give you the results for the energy savings and also for the emissions. And then you can also download the results. So you can download the empty Excel file that does these calculations. You can also download the results in an Excel file, so you can see what affects what and how you can improve these results. There are also, of course, a guide to using the platform. yeah, and that's it for the methodology. So now we, together with the Copper Institute and other partners in 6 countries, are working on this EU MORE project, which is the European Motor Renovation Initiative. And the main objective is to develop policy recommendations to improve the renovation rate of old inefficient electric motors still in use in Europe. So we are now, the project has been running for more or less 1 year, and we are gathering data to develop a model to analyze different scenarios of policy implementations. So we have gathered some motor market data that will be used as a baseline for the different scenarios. And also we have carried out a review of the existing policies in all countries, in all European countries, that address directly or indirectly motors and motor systems. So we will be publishing this. These are in the final stages of completion, so we are gathering we have still some uncertainties and gathering some data still, but this will be published in the next few months. And then the next objective is to share knowledge between different actors involved in this area, in this field, and promote discussions and knowledge exchange. So for this, we have an online platform, but we will also be carrying out some dialogue meetings where people can share these meetings are online, so where people can share their experience on these issues also. And then we will, based on these collected experiences and information, we will propose new policies that would stimulate the replacement of old inefficient motors, and also look at the entire system. One other aspect that we look at is, because we are dealing here with the replacement of motors, we also, of course, have to look at material efficiency and end-of-life behavior. Actually, we are carrying out now interviews with people that are experts on this issue, so that we can understand better what happens to motors at their end of life. Now we can also improve material efficiency in electric motors. So if you want to be informed on the developments of this project, you can go to the website. I think Fernando has put the link on the chat. So you can go there and then subscribe to the newsletter. You can also subscribe to the knowledge exchange platform, where we will be promoting these discussions in the next few months. So that's it from my side. Thank you for your attention.